Dear students, welcome to the knowledge series with respect to the membership graph. Now we will be seeing some membership representations and based on its plot, and based on that particular membership plot we will try to see the value of x and y. Y is indicating the membership functions value or the degree of membership and how we are going to set it, and why that particular membership is essential, that going to explain to you with an examples so that it will be more clear to you. As I have already termed that fuzzy set or a fuzzy logic is basically, it's not a logic but it's a logic that is describes the fuzziness. So when I say describe the fuzziness, or the fuzziness that is characterized by the membership values. So let's take that this is one membership graph which is being shown over here, and this particular graph is being describing the level of salaries, and based on the level of salaries the membership is defined in terms of a false, definitely true, generally true, absolute true, and true. That means under this particular graph, any salaries which is falls under this range, if it is 7k then we put it as a definitely, 25k it is generally true, like that 35k then it is absolutely true, and 40k is true. But fuzzy is basically different as compared to the crisp. Crisp will be having a definite condition like 7k, 25k, 35k, 40k or 4k. But it crisp does not talks about the intermediate values. So to know about this intermediate value we take the fuzzy conditions. But that fuzzy logic that describes based on these values or the fuzziness value. So say for example, let me put like this one. I am putting a one notation here. That will let me at this particular x value, what will be the salaries. So at this particular x value, if you try to take it, so its salary, no, not salary, where it falls. It will falls between definitely true or a generally true. So how much portion of a definitely true or generally true? So that is that will be determined based on the fuzzy's way of the membership is being distributed or the propositions. So those, that is a different further mathematical and logical discussions, so that we'll see in the later part. However, suppose when we talk about a salary, if we don't know, we will say that normally the people say that my salary maybe generally it comes around, or it may be definitely, or that particular terms is there, or it may be definitely or that is a closeness value, or a generally some closeness value, like that terms is used. So these are something like a linguistic terms, not a concrete numerical value of any particular figure to state that based on this statement your x can be determined. However, the fuzzy set goes with such type of a statement to know where this particular statement it falls. So that's why it needed several number of memberships, and thereby we can able to determine. So here suppose a 24.5k is be shown over here. 24.5k is less than 25, so it comes under the definite true and generally true conditions. So based on this x value, our f of x will falls here. So from x we can able to map f of x, and or from f of x we can map to x. So this is what we do in the case of a fuzzy set. Now let's take another example, low salary and high salary. So this is a membership plot with respect to, or a graph with respect to the high salary, and this is with respect to low salary shown. So anything which is between 4 and 20, we take into considerations this particular plot and of a membership, and whenever it is 20 onwards we take this particular plot, whatever it may be. This is you should not get confused between the low salary. 20k means low salary and 4k means high salary. This is not the things what exactly is talking about. It talks about if suppose if the membership is like this, so what will be the situation under the 15k. So under the 15k the membership value will be half of this one, that is 0.5. And if it is a 4k it is 1, if it is a 20k it is this one. We can take in here I have put a low salary as in terms of a like this plot, but we can take an example like this one. A government is giving an incentives or an allowance that those who are having a salary of 4k, they will be getting an allowance of 1, and those who are having a 20k, they will be getting no allowance. So like that, and those who are in between the 4k and 20k, they will be getting a 50% all. That way also you can treat it. But here the point is not with respect to the subject, rather it is with respect to the title that is being put related to the membership value. So so this is a continuous curve concept. So that is what is termed as a low salary and a high salary with respect to continuous curve. Now here one thing you should remember, that the variable can be represented as a continuous curve with a suitable level, and the variable will have a definite level of truth are known as each fuzzy set values. So for this truthness, so automatically you will have some set values. So that is what here this particular graph it is being stated. Now let's see the another one graph. If you see this one here, this graph intersect there is no intersection, it meets at this point, and from here the another graph starts. Now here if you see the same graph, but it has a point of intersections, that is there is a crossover is there. So crossover is taking place here, so there will be a this is one set, this is another, so there is a common point of an intersection is there. So under these conditions, so this is the range between suppose he is 20 to 40, so they will come under this particular form of a curve. So the membership work functions which is being shown over here, the range of a 20 to say let us take this is up to say 50. So 20 to 50 will be maximum treat under this one, and if it is a beyond and if it is a beyond 50, then automatically this one. But here also if you look into after beyond 25, it will be taking into consideration this point, this point. So the complexity will be increasing accordingly. But you have to remember that if it is intersecting at this point, it will take into this one. But if it is intersecting at this particular point, it will this curve is taken. So this becomes a minimum point, and if it intersects, then it is become a maximum point. Like that, a further complexity will keep on increasing with respect to the given set value, but having two different membership values. So there is an evidence that a low salary and a high salary encompasses the two crisp region of salary. So that is the it is not a single region, rather the two regions is taking into considerations. Hence this two continuous curve must overlap, and this must give some logical rethinking, so logical look also, because here the more logical considerations and real world representation is coming into these particular situations. So it is not like a previous figure. Under these conditions, the complexity of the membership function increases, thereby the fuzziness complexity also increases. So this gives a more preciseness as compared to the previous membership values. Now let's see the another figure. Here in this particular figure, if you try to see, is that as I stated with respect to the previous figure, Now, if this figure is being represented in under the situation like a 25k, the same figure, but it is shown under 25k, you will be having a two membership value, 0.4 and 0.5s. So now under the 0.4 and 0.5, so the salary of k, here it is given, salary at 25k has a membership of 0.5 in the lower LS and the 0.4 in the HS. So that what I mean to say. So as the LS salary, that is a low salary with shows a higher membership values, whereas in this case at 25k with the higher salary shows the lower membership values. So that is the terms what I mean to say. Hence this numerical value of a 0 to 1 can be assigned to a salary depending upon the fuzzy set of a x and a mu x condition. And these numerical values which is shown over here ranging from 0 to 1 under the decimal value is termed as a degree of a truth or a membership, degree of a membership or a truth functions. So degree of a truth, degree of a membership or a truth function is that is what we termed in this particular case. Hence this particular representations of the membership functions quantum the truth in terms of the membership figures or the membership graphs that is being used to determines the various conditions of the membership situations as well as membership class. So here I have shown something like a triangular structures, or it is like a trapezoidal shapes, or sometimes we can go like this shape, sometime a general it is just like a bell shape or a Gaussian membership function. So there are different type of a membership functions you can see. When you take a MATLAB and when you type the fuzzy, automatically the fuzzy tools will pop up, and there you can able to see the different conditions with respect to the fuzzy. Now here further I have to talk about something related to the fuzzy set, related to the non-cave and a concave fuzzy set. Now when we see the non-concave fuzzy set, it has been stated as non-cave fuzzy sets are a fuzzy set in which a membership functions alternately increase and decrease of the domain contained at dips. So it is increasing and decreasing, but it is keeps on fluctuating up and down. So what exactly mean by non-concave? Non-concave means that suppose you are having in this particular graph you are having a point here, so and there is another point here. So if you try to join these two, so it will start from here and it will meet here. But after this, what happened? This line, if you extend again further extend, it will try to meet the same set, but having another point also it will try to intersect. And again further go, it will try to intersect here. That means if you try to map membership function to the x, instead of having a 1 value or a maximum say 2 value, it will try to produce a 3 to 4 values. So 3 to 4 value, it indicates that the membership functions that you have selected that is little complex and having a fuzziness in that one, it shows. So the more the fuzziness, it will show the more the fuzziness with respect to the membership function, the fuzziness value will not able to produce a exact approximations. So that is what exactly it means. Now if you try to see this particular figure, here also this is a non-concave, or this figure if you see, this is also a non-concave situations. So that is what I mean to say in this case. Whereas when you talk about a concave, it is that one which has all the element within that set. A set of points such that a given 2 point P and Q lie entirely within that set. So all the elements within this set joining 2 points or intersecting 2 points, so that is termed as a concave. And non-concave, the 2 point line P and Q is externally that is does not remain completely inside the set. So here P and Q is not remaining inside the set. It is going out and again meeting. So any set which is intersecting, but it is taking a internal as well as external boundary, then that particular is a non-concave set. Now let's see the another point with respect to the concave set. As I explained earlier with respect to this, if it is a triangular set, then you have a 2 points. So this is a concave set. So it will have a 0 point and to the 1 maximum membership function. If it take a trapezoidal case, again the 2 point is but it is within that set. So in a concave fuzzy set, membership grids do not alternately increase or decrease. That means that the membership function of a convex set does not contain a dips. Dips means like this type of changes will not be there much. So that is what exactly means with respect to the concave set. So these are the basic content with respect to concave and convex set. Now finally let's see this portions related to the partition and covering. Partition means this is let us take this is one rectangular area where we are where we created a different areas like a clusters, A1 cluster, A2 cluster, A3, A4, A5, A6, A7 and A8. Like that different cluster of sets or different sets we have created, and inside that several elements are there. So inside AI will be having elements. So this is known as a partitioning. So this is a partitioning means this is one partitioning, this is another partitioning, no interfere. But there is an overlapping condition, that is a covering. So there is no intersection, there is an intersection, that is a overlapping. So here if the same figure is if this is A1, so this A2 if you stretch it, it comes here and it forms a figure. Similarly A3 if you stretch it, it becomes intersect with A6. A4 intersect, if you stretch it, it intersect with A6. A5 is independent. A7 is intersects with A1, it becomes like this. So A8 if you intersects with this one, then it creates a intersection point. So this is basically gives an idea about a union operation as well as a intersections operations. So these are the again a part of the fuzzy set distribution study with respect to the finding out the set, and if it corresponding to a membership, then if such type of membership if evolves, how that particular membership has to study and logically think for consideration. So these are the basic important segment related to the fuzzy membership functions. I believe that I think that this has given to you a certain idea about this fuzzy sets and its membership functions, and with respect to the various graphical structure representations.